Wait a minute.
Hello, everyone. Need your attention for the next 60 minutes. I'm not going to say a minute. So it's my pleasure to introduce the next keynote speaker, Matti Latva-aho. A very quick bio. So Matti received the MSc and then the Doctor of Technology Honors degrees in Electrical Engineering from the University of Oulu, Finland in 92 and then 98 respectively. From 92 to 93, he was a research engineer at Nokia Mobile Phones in Finland. And then he joined the Center for Wireless Communications at the University of Oulu. He was the director of CWC from 1998 to 2006 and the head of the Department for Communication Engineering until 2014. Currently, he's a professor at the University of Oulu on wireless communications and the director for National 6G flagship program. He's also a global fellow with Tokyo University. He has published over 500 plus conference journal papers in wireless communications. He received the Nokia Foundation Award in 2015 for his achievements in mobile communication research. So with this, I request you to welcome Matti.
Good evening, everybody in Bangalore. And it's a great pleasure to give this keynote talk tonight, but unfortunately, I had to make it virtually from my home. Hopefully, you will be able to receive my message. Anyways.
So we can't hear you. We'll check the system and let you.
Let me check once more. You should be able to hear me. Mic is on and everything seems to work from my end. And everything was working when we tested. You should be able to hear me. Hello? So it seems to be the problem is at presentation mode at the venue.
So please wait for 2 minutes, like we are checking the system.
Can you hear me in the auditorium?
Yeah. Now
Yes.
we can hear you. Yeah.
Okay, great. Okay, let me start over. So, good evening, everybody in Bangalore. Unfortunately, I cannot be there with you tonight, but hopefully you will receive my message well, also from through remote presentation. I'm going to talk to you tonight about a little bit about our flagship program. Try to motivate you why these local 6G connectivity solutions are of great importance in 6G era. And also I'm talking to you about a little bit about our general views on how 6G might start to look like. So our flagship program was started mid-2018. We are the first major 6G research program globally. We are 8-year program officially, but our university has already decided to run it until the end of 2028. We are completely operated by University of Oulu and relatively big size program, over 400 researchers currently from about 50 nationalities. We have been very active in trying to write some visionary papers, let's say, trying to lay down the research challenges of 6G at early phases of our flagship, as well as being active in publishing lots of papers related to future wireless technologies. Our research agenda is relatively broad and I would say to some extent a little bit unique as well. Besides the standard technology trusts of different sorts that we are pursuing research along with, we are also active in regulation processes, for example, We are the official representative of Finland in ITUR, working by the 5D work currently. We also have some researchers from business school who are looking at future business prospects related to 6G era. We are trying to challenge existing mobile network operator-centric business models. And also sustainability development targets are, let's say, overarching theme at most of the research that our university is doing these days. In Europe, these things have become really, really important these days. We have 4 strategic research areas, and along with we have different research themes looking at different important aspects related to 6G solutions. Wireless connectivity is the area that I'm personally leading, where we are looking at different future advanced networking technologies, definitely looking at how to evolve with these wireless broadband solutions, as well as looking at different aspects related to massive automation via different wireless solutions. Device and circuit technology research is also very important when we are trying to push capabilities of 6G to the limits. How can we really implement radios in the future? We are looking at different hardware building blocks that are necessary for making those real different IC related solutions, antenna solutions, power amplifier solutions, and so forth. Then we are developing all the time different complete radio platforms at different frequency bands, which we are trying to utilize in our experiments and proof of concept activities. We do have quite extensive 5G test network currently, which we are pushing towards 6G era and ready to be used for 6G research as well, and which we are then testing against different vertical application areas, which I will show you in a short. And then sustainability and related businesses are also being studied in one group. Distributed intelligence, very important, how we can use edge intelligence in future wireless networks, how we can use distributed AI in wireless networks, how different types of gadgets can be used to compute partial solutions related to AI. And then distributed sensing and related modeling activities. Besides these strategic research areas, we are trying to be active in 4 vertical application areas: health, industry, vehicular, and energy sectors. We would like to understand deeper and better how these different segments of society function, who are the key stakeholders, how the future businesses around these vertical areas should be developed. And also we try to understand how the revenue for different players in the field is generated. We are very active in global collaboration activities, and here are some flags of our key collaborators around the world. India flag is also there, and we are open to any new suggestions. So if you are keen on trying to collaborate with us, please contact us, and we will see what we can do about it. I mentioned already that this 5G test network and in the future the 6G test network activity is one of our targets that we are having in our flagship program. And actually our government has set as a national priority, one of national priorities, to have test network facilities for national R&D activities to be developed within the next few years. So we started our journey to develop 6G test network already back in 2015 when we were still developing 5G. And our first deployment was based on small cell LTE products and some proof of concept devices, which we used in Pyeongchang Olympics within one European project to demonstrate some of the 5G capabilities that were foreseen already at that time. By 2019, we actually had our first live 5G test network, which we call local 5G operator network. uh, around our campus live, and it's operator grade, and we have our own SIM cards and test users that are doing different validations related to our proof of concept radios. Then lots of developments ever since then have happened through competitions in national research infrastructure roadmap thing, and also we are now on the way towards European first wireless test network roadmap in this Lysis RI project, and hopefully we will be able to make it during the next few years to that end. But anyways, now we are busy developing 6G test networking capabilities, and we are following three thrusts there. First of all, we are following exactly what is being done at 3GPP and with different releases in collaboration with our industrial partners, and we have a chance to utilize their latest commercial products and plug them into our test network. Then, secondly, we are now having also some Open RAN capable components that we are plugging into test network, where we can also, let's say, twist and tweak more of the networking parameters, radio access network configuration, and so on, and with software configurable platforms that are in the labs. Then the disruptive 6G path is mainly RF driven, where we are trying to actually develop radio concept above 100 gigahertz, somewhere between 200 300 gigahertz frequency band, where we would try to push radio capabilities to the limit and showing some extreme applications that 6G might actually be needing. So this is somehow showing the path how we got here, and we have already quite successfully implemented several uh, vertical use cases, from medicine to harbors to smart grids, factories, drones, and most importantly, our university serves as a smart campus test site and environment, where we have over 2,000 sensors wirelessly connected to our test network, and we can utilize it in multiple ways to try to make our campus environment smart in many respects. Our current setting has lots of different radio products working at different frequency bands, and of course there's a legacy from 4G, of course, since we started 2015. But anyways, they are all installed there and functional and working nicely for different types of projects that we are having. Okay, so now let's move on to 6G visions and how the world might be developing towards 6G era. Uh, Development has taken really place in 20 years time cycles. The first 20 years was voice-driven era. Now we are in the middle, still we are in the middle of mobile broadband era, which started with 3G and is still the main use case, or let's say use scenario that we use our mobile networks for. And the next wave, which is supposed to start right as we speak, and it's actually gradually happening, we don't know yet what is going to be the killer application, but there are some indications of what might be happening. 5G brought along, let's say, different industrial players to the value chains, and we had machine type communications coming in, a massive automation of different processes, not only in industrial processes but in society, and bringing in intelligence to be part of wireless networks. But really, we don't know what is the next big thing that we will remember 10, 15 years from now, that was really the killer app for 5G, 6G era. Um, The key drivers why we need 6G there are multiple of those. First of all, there are a lot of societal challenges that really urge us to come up with smart solutions how to do things more efficiently in a more sustainable manner. Digitalization of societies is really needed for saving energy and natural resources. That is really the key thing. Then, secondly, related to that, United Nations has set these sustainability development goals, 17 of those that should be reached by 2030s. Lots of challenging targets which are related to these societal challenges. These, I would say, are a little bit like soft targets for future networks. Then, at the hard side of the drivers, we have several technology enablers which will be making smart societies of the future reality. Wireless connectivity solutions is definitely one of those, but we have many others as well. AI developments, robotic, autonomously moving vehicles of different sorts, and electrification of moving things, many different things. And still, this number four, verticals productivity. This is how 5G actually was pushed forward and marketed initially, so that different verticals need to be improved. The processes need to be enhanced. Productivity of industrial manufacturing has not been developing as fast as could have been expected. This current so-called industrial revolution that we are living in now requires new solutions for productivity improvement. So all these corners result in different types of requirements. Somehow we have to try to meet the requirements coming from societal needs and requirements, as well as these technology development possibilities. And having said that, we can separate these key values to be very technical driven KPIs or society and sustainability driven values, KVIs as we call them. So these KPIs are very easy for us researchers and engineers to understand. These can be measured easily numerically. We can put numerical targets to those. But then these softer KVIs are hard to quantify numerically. But those are very important to keep in mind when starting to develop the next generation standard, and even when defining the requirements for the next generation system. We do believe strongly that different types of vertical applications will drive the development of 6G technology in the end of the day. So far, we are used to the fact that we have one uniform radio concept, or the communication system concept, that is applied with some parameter settings which can be altered slightly to all kinds of applications. But it starts to look like that is one solution fitting all possible application areas thinking is getting to an end when we try to efficiently deploy wireless technologies to so different application areas. Also, thinking about the current huge need of energy efficiency in all societies, and also including wireless communication solutions. We cannot waste resources and energy by allowing this one solution fitting all problems thinking. We really must afford quite a bit of customization of solutions fitting better to different important application areas. Here is one table showing, this is an exercise that we did a couple of years ago, maybe 3 years ago, typical vertical application areas, and with some thoughts about the types of applications that would be needed in the future in these different verticals. Typical parameters related to data rates, latency, link budgets, jitter, mobility, capacity, you name it. Without going into any of the details, you very easily see from this table that the numbers differ hugely from one vertical to another. So this really gives you an idea that we cannot have one uniform solution that we try to push to all kinds of application areas. A lot of customization is actually needed. How to do that is another question. But 6G is needed for the massive automation of society. 5G is a start of the journey towards that. It's a good start, but lots of things need to be taken further. We have to try to push all capabilities to the limits and try to see, can we do that in reality efficiently, cost efficiently, and energy efficiently, at the same time as meeting the communication requirements of different application areas. And also, as we have seen during the recent years, that artificial intelligence seems to be one of the game changers related to future digital societies. We also have to try to understand exactly how and where and to what extent we can utilize those techniques and algorithms in fine-tuning and optimizing network solutions, and more so how to implement future applications with the assistance of different machine learning algorithms. And also, in order to make this future digital society happening holistically, and let's say a little bit pushed by market forces, I think we need also major innovation for the business ecosystems, which currently still are very much mobile network operator centric and driven. So future society really, smart cities, they really require new solutions and more holistic thinking. This is very simplistic picture what is happening currently, but there are so many different corners and application areas related to smart living environments that one can look at. And of course, the wish is that the 6G would take care of, if not all, but most of these application areas. What we try to do in our research is that we are focusing our efforts in smart campus area, which is a small scale version of smart city with all kinds of different functionalities, all kinds of different technologies need to be used in order to have really fancy digitalized campus for the future. If you look a little bit back, like 10 years back, and try to see how 5G was seen when we started to do research and development towards it. This is one table from European research visions from 2013. And if you look on the left side, if you can read it, what 5G will bring to you, there are things like amazing volume, amazingly fast, always best connected, no perceived delay, massive amount of connected things and people, energy efficiency, flexible programmable networks, secure networks. All these big targets are valid today. These are valid for 6G development. We haven't been able to achieve these yet because these are really, really great challenges and definitely worth going on even today. 5G was the first step towards achieving these, but it doesn't mean that it's end of the world and end of the story. We have to push everything to the limits. These are really, really valid targets today. And in 2015, ITU defined 5G requirements for IMT 2020, as we remember, with three corners: extreme mobile broadband, massive machine type communication, ultra reliable low latency communications. These three corners. with different parameters of peak data rates, latencies, etc., etc. Similar thinking will be done very soon by IMT 2030 requirements driving 6G during the next 2-3 years. We don't know yet how many corners will be laid down then. The discussion is now ongoing. They are talking about 5 or 6 different application scenarios, but we will see after next summer when the bigger ITU meetings take place, what are they going to actually suggest. But looking at what research community has suggested so far, this is somehow a collection of what has been publicly presented in different venues by different players. These are not our visions or targets for 6G, but people talk about terabit per second peak data rates. They talk about very accurate positioning alongside with mobile broadband. They talk about very small latency, like a sub-millisecond. They require much more energy efficiency than today for very long battery lives, etc., etc. But these are very contradictory system requirements. So we really cannot meet all these different targets at the same time, and we need different corners for these requirements in the future. So we can never satisfy all these different requirements at the same time. It depends on the application area, what are the exact targets. So customization is needed. But also what we try to explore deeper and deeper is that the network capabilities are no longer going to be uniform, but they will be very much context dependent. So you can equip your network with different capabilities depending on how much you want to invest, what types of applications you really would like to have within certain geographical location. That's how we see the future. Broadband connectivity is, of course, still probably one of the key driving forces towards 6G. And when we look at what are the different techniques that we researchers all around the world are working with today, there's nothing really groundbreaking new. I mean, lots of same things that we have been working with very long time, taking it further to extremes, but nothing new at all. And the key question in the end of the day is that how much improvement can we bring to table with the latest advances in these very much signal processing oriented new solutions, or what should we do? Actually, if we try to remember what happened already with 4G and 5G development, we were saying at those days that we can increase capacity by having more spectrum, improving the spectrum efficiency, and by spatial splitting of the cells, so densification of the cells. And the most efficient way of increasing capacity is to have more spectrum and cell splitting. So that is already a conclusion that we found out more than 10 years ago. And there is actually a possibility to have more spectrum when we go to higher and higher spectrum bands. 5G had a big promise of utilizing massively millimeter wave frequency band for capacity increase. But now that we look at what is happening everywhere and where the capacity increase is coming from, it's not from millimeter wave band massive utilization, but it's still we are using this lower spectrum band and having higher bandwidths at lower spectrum bands and having carrier aggregation and all these traditional ways of increasing capacity. Plus, of course, we have very fancy MIMO solutions that we are trying to deploy today, which has taken us to rather energy inefficient solutions of 5G. And there we are. We have some sort of a challenge there. But what does it mean that when we are going to higher and higher frequency bands? At lower frequency bands, mobile network operators have invested fortunes to buy the spectrum bands at these relatively good frequency bands, and we have more and more flexibility when we go to higher spectrum bands in allowing and having new entrants, also locally utilizing the spectrum. So maybe the verticals can start to drive the future ecosystems deploying these higher spectrum bands. So far, there are not huge amounts of new entrants. In every country, the mobile network operators are still, of course, the most important and powerful players in 5G networking. But we need more players. We need innovative thinking. We need to be more flexible in spectrum licensing policies, especially at higher spectrum bands, in order to make sure that we have sufficient capacity for future systems. We started to talk about micro operator concept maybe back in 2015-16, and it started from this kind of thinking that there are different types of spaces and places in modern societies where the types of applications and networking requirements are very different. Also, the players operating at these different types of environments are hugely different. So we said that actually the owner of the space must have a role in future networking, building, operating, maintaining, and defining what types of services are offered in different locations. So we came up with this micro operator concept where revenue models are quite different. It can be part of property offering or inclusion of rent, part of customer service models, or if it's related to public services, then it's bringing in savings for society. In large scale, this is not possible even today. We have these private 5G network solutions, but they are closed. The name says they are private, and they cannot be accessed by visitors, for example. So the question is that will the time of local operators come along with 6G? There are lots of interesting technical building blocks that we foresee already 5-6 years ago that are needed. They are now coming into place. There are lots of developments which are actually suggesting and hinting that yes, we are going towards that direction. There are different software-driven networking things happening, Open RAN, and there are lots of new spectrum bands being allocated to private networks all around the world currently, and at increasing speed. Lower spectrum bands and higher spectrum bands, which are making this possible. And in regulatory domain, first thing is to have spectrum available, but then there's also still lots of things to be done in regulatory domain. For example, if we foresee that these local networking concepts are actually becoming important part of future solutions, then what we would need to have definitely is roaming between mobile network operator networks and these local networks. For example, imagine a university campus which has implemented local network based on whatever technology, 5G, 6G, you name it. We would at least allow anybody visiting campus coming from any operator to be able to access our network. But that should be allowed, and that is, of course, agreement between operators. So these things are now happening in private network scheme. And I just this morning Googled a little bit and tried to find out some recent developments, actually stating that yes, this is happening right at the moment and important thing to look at. There are interesting pilots ongoing in Europe, like in Netherlands. They are actually having really good part of spectrum where they are running at Schiphol, Amsterdam Airport, a very interesting pilot case right at the moment. And GSM Association presented very recently latest data on how widely these private network deployments have grown around the world. So there are about 1,000 private network deployments pretty much all around the world at the moment. NTT contracted a survey last year where they interviewed more than 200 different types of companies and interviewed the CEOs of companies and asked their opinion about their views on deploying private 5G. And about half of them, a bit over half of them, said that they will deploy private 5G within their corporation between 6 to 24 months ahead of time, which is really a strong statement. There are many reasons why they want to do that, but that's what they're planning to do. In Japan, which is one of the big forerunners in private 5G networks, which they call local 5G, they have big expectations in revenues, like this chart shows. These are billions of Japanese yens, and growth is expected to start actually steadily growing from this year onwards. So interestingly, in Japan, the local 5G is not allowed to commercial mobile operators. This is one of the potential problems that we will be facing if mobile operators are pushed aside of this local networking paradigm shift. Of course, it's easy to see that they will never support it strongly if they cannot also have a chance to enjoy it in the future. And I think, in my opinion, it would be a big mistake. So to summarize a little bit about what are the key drivers towards 6G, there are four major points: societal, business-related issues, standards, and technology. From societal perspectives, digitalization of all societies is very important for the future of basically our planet. I mean, we have to try to limit emissions, and wireless technologies can be a big part of that development. Now, if we say that okay, digital services and solutions are needed for the sake of the future, then we are also having a big challenge on remote areas connectivity and also poor areas and poor countries. How to enable even rudimentary level services so that they can enjoy at least the early steps of digital solutions. That is important also. These new ecosystems and disruptive businesses, I think I discussed most of my talk, so no need to go to that any deeper. Global collaboration and standardization is important. And now that ITU processes start to be more clear and they start to also put into the timeline when different things are going to happen, I think it's very important to support that development. And at least currently, it looks like most of the bigger infrastructure providers and operators are supporting today one global standard also for the future, which is, I think, very important thing. Then about technology, data privacy and security is one of the critical things for the future. If we imagine that wireless networking concepts will be deployed all parts of society, and even possibly by a huge number of new players, these new local operators, then we have a higher risk related to security than currently. So the number of so-called risk factors is increasing like crazy. So these data privacy and security issues and precautions to prevent damages happening is becoming more and more critical. About the network architecture, currently we are very much RAN centric in the network's deployment and architectures, and that has led to the fact that we have same geographical area is covered by multiple different operator networks, which is in a way it's huge waste of resources. And so if in the future we can develop more service-driven network architecture where no one actually in the end of the day cares how the wireless access and access to the networks and services is organized, would be more sustainable and would allow different players to build part of the future overall network. Super efficiency at higher spectrum bands. Efficiency can mean extreme speeds, extreme reliability, extremely low latency, extreme sensing or localization accuracy. I think those can be achieved only locally with rather short-range networks that are using higher spectrum bands, even above 100 gigahertz spectrum band. Then utilization of machine learning and AI in networking and applications is, of course, now one of the trends that most of the researchers are following, and it remains to be seen how much it will be utilized in the future, but definitely it will be one of the key building blocks. We have investigated and actually have defined lots of research scientists related to these four critical drivers within our 13 white papers that we were published already some years ago. So if you're keen on digging deeper into these thoughts, please visit our website and download the white papers that we have made available. Other than that, we are also publishing actively 6G Waves magazine. A recent issue came out just a few weeks ago, and every June we are organizing jointly with European Commission EU CNC and 6G Summit. This year it will be organized in Gothenburg, Sweden, and the paper submission has just opened, and as well as special sessions and tutorial proposals, etc. So if you're interested, please follow that and make your proposals there. Now, thank you for your attention, and if there are some questions, I'm happy to answer those.
Thank you for the talk, Matti. So the floor is open for questions. There's a mic going around. Just raise your hand and we'll get you the mic. Please do speak in the mic so that he can also hear.
Hi, Matti. This is Varun Kumar from Carnegie Mellon. Great talk. So one of the questions I have is also from a discussion that we were having earlier. Do you think it makes sense at some point to transition from the different Gs, like 4G, 5G, 6G, to something where networks upgrade in the back end, sort of, a software-based stack, sort of similar to the Open RAN vision to some extent, where networks sort of get upgraded in the background, sort of like how our cell phones do or how our cloud applications do. And at what point should that transition happen, or should it at all, or can it at all?
Very good question. Thank you. I heard recently, a few months ago, very interesting talk by one of the senior Japanese influencers in the field, and somebody asked in a conference from him that how many Gs are needed before we don't need any more standards. And he said that 12G, based on his detailed analysis, is fully software based, no human touch, completely AI designed. That's what he said. But but I think there are already groups who are quite seriously thinking about the world without standards and let AI design completely everything. So and everything is softwareized and so forth. But there's one drawback on that currently, based on the implementation technologies that we have today, is energy efficiency. If we go very much in the software-defined solutions, then we lose a lot of energy efficiency at the very least. Those can be communication, as a communication system, they can be extremely efficient. But energy efficiency doesn't look very promising yet. But the time will come at some stage, hard to say when, but not with 6G. That's my thinking.
Hi, Matti. This is Manisha. Thanks again for a really good talk. So one of the things that, and I've asked these to many of the wireless operators as well as the equipment providers, is when the move maybe was made from 4G to 5G, it's still being made. Most of the gains we are seeing are really due to bandwidth. When you go from 20 megahertz to 100 megahertz, you get 5 times the throughput. That's a no-brainer. The additional gains that were supposed to come from massive MIMO or millimeter wave are largely not happening yet. And the question as we look forward to 6G, so let's assume 5G gets to where it's supposed to get in terms of spectral efficiency. Now, should we still talk about 6G as being a totally different standard, or should we think about 6G as being new frequency bands that maybe we can take the same standards that we've developed for 5G and implement them there? And so the question, similar to what Swarun says, is why do we constantly need to churn the G so much? Can we not have, and some of the lessons we can draw from Wi-Fi is that, we keep getting new Wi-Fi generations, but they're all backward compatible. The way we are doing the Gs is not really sustainable, in my opinion, that every 20 years we rip out a network, we put in a new network, we throw out all our old phones, and we have to get new phones, otherwise we can't function. So I'd love to hear some of your thoughts on that.
So very, very, very good point, Monisha. When we started our 6G program, you may just guess how much we were charged and challenged by industry that why are you talking about 6G since we don't have yet 5G? Well, we had very selfish reasons to do that, funding basically. But when we then had a let's say little bit better answer to them, we said that what we mean is that the wireless technology or wireless networking solutions that we need after 2030s. That's what we are looking at. We don't care is it one 6G standard. It's a group of different technologies that we need, and it's more kind of the communication systems that we need in the next decade and beyond. But I agree with you completely that the capacity increase has come through bandwidth increase. And I don't see why it would be much different from that, except if this paradigm shift to cell splitting starts to really happen big time. We started to talk about these femtocells and small cells in 4G era, but it never took off. Never took off for many different reasons. And I don't think any of the reasons was technical. Technically, we have products that we could utilize even today in massive scale, but it's more of regulatory decisions. Who has rights to operate the networks? Now, recently, all countries are following this private 5G development, but it's private networks still, and that's not enough. we should allow also this cell-splitting paradigm also to more public or open deployments of networks. I don't know why we have these Gs, but at least it's a way to sell more infrastructure products.
Any other questions, folks? There's one. Yeah.
Hey, Matti, thanks a lot for the good presentation. So I'm Satish from Nokia. You actually talked about an interesting thing that actually intrigued me is the concept of this local operators, micro or virtual. So what in your mind would be the aspects? I mean, whether it is technology building blocks or whether it is policy related stuff that would really enable us to get to that stage in 2030s. I will now hesitate to add any number and G, but say in the next 10 years, if you want to get to that state, your vision. I mean, what would be the enablers for that?
Yeah, thank you. So, as I mentioned earlier, spectrum bands are allocated at increasing speed for private 5G networks right at the moment. And the next step that should be taken is to allow roaming between macrocellular networks and these private networks. If you think about places like shopping malls or any public places and spaces, so if you are running a shopping mall, you definitely would like customers to have chance to access the privately deployed network, which you deployed there for a specific reason. Exactly like in private networks in factories, you do that for specific reason. Also, these local network deployments are for specific reasons. You have different characteristics, different features, different applications that you run only locally. And that requires roaming. And if this roaming would be a requirement in publicly deployed private networks, then I think this would fly definitely. But it comes along with some challenges related to reliability of these local connections, security of your data in these private networks, and so forth and so forth. So it's not easy. It's not easy, but that's, in my opinion, what should be done, allowing roaming to these local networks.
All right, so it's 7:35, so I think we should stop the session. So first, let's thank Matti again for agreeing to give us a keynote. A big thanks, Matti. And we do hope we can see you in person next time here. All right. Okay,
Sure.
so thank you all for coming. It's quite late, 7:30. It's been a long day. So, well, good night and see you tomorrow. Rajiv has an announcement. Just 1 second, guys.
Should I end this session? Yeah. Should I end this session?